In our second video for today, we're going to be starting our next unit, Unit 9, which is going to be our second to last unit for our school year. This unit is called Circle Properties and Radian Measures. Essentially what we're doing is expanding our definitions and expanding our knowledge of what makes a circle. Besides the lines and segments and measures that we can make inside the circle, now we're going to take some of the various concepts that we've had throughout the school year and see how they interact with the circle beyond its boundaries. What I like for you to do is just to take note of this. Our notes for today are very definition based, and what I did is I attached in Google Classroom a copy of, or like a PDF say, of today's notes so you can kind of follow along in that fashion. You don't have to necessarily write everything down that you see on the screen. You can just copy it off that nice and easy to read text file. So let's now transition down to our notes, and what you'll see written down already is our circle labeled point with point C being so circle C. In circle C we already have written out here our diameter, or diameter of dB. We also have what's called our radius of CA. What we're going to be adding in terms of our definitions for now is some new pieces of information. Thus far we've drawn segments that started essentially from our radius or extended through our radius, which would be our diameter. The next thing that we're going to add as an example is going to be called a chord. And a chord is essentially a segment which has two endpoints on the circle itself. The way that we can represent this or draw this out is basically just draw a little short segment that connects two different portions or two endpoints on our circle itself, and it does not necessarily have to go through the center point, that HK value. So here we have just EF. Once again, that's just going to be a segment with points on the circle. It could be something like, for instance, a diameter. A diameter does technically have two endpoints on our circle. But diameter is special in that it goes through the center point. The next thing that we're going to do is draw what's called a secant. And a secant is going to be a line. So a line, as in going back to that original definition from earlier in this school year, as in this one-dimensional figure that goes on for infinity. So our secant that we're adding here, we're going to call it line G, or what you could say line GH. In regards to our definition, our secant. So a line that intersects a circle in 2 points, going through the object, almost like the plane drawings that we drew so many moons ago. The next figure that we're going to be adding is going to be what's called a tangent line. A tangent line is something that doesn't necessarily go through multiple points of our circle, but what it does is it hits just one little tiny spot of the circle, essentially that most minute portion of which we can calculate a circle, that measurement in between a measurement, in between a measurement, in between a measurement. For here we're going to label this J and K. K is going to be the theoretical point where our interaction occurs, or our contact occurs. And we'll label that the point of tangency. So if you haven't seen your definition already, tangent is a line, segment, or ray that intersect a circle at exactly one point. There's only one little minutia gets interacted with. The next thing here, we're going to draw out our central angle. Our central angle we've referred to in our previous lessons before. Our central angle in this particular example we're going to call ACB, or angle ACB, and it's going to be an angle whose vertex, the center point of the angle where it actually bends out, is at the center of the circle. Next thing we have here, just an arc. We've mentioned arcs before. The way we've drawn arcs are in regards to radiuses, but we have a new term that we're going to be adding today. An arc can be any of these spots that are along here, like for instance, which is written down in our notes here, FH, a portion of a circle, this little guy right here. We also have what's called an intercepted arc. And an intercepted arc is going to be an arc which lies between 2 points formed where the sides of an angle intersect a circle. So essentially we need a central angle. We need to be coming off of our radius. As such here, AB would be our intercepted arc. So if you want to differentiate between an arc and an intercepted arc, to visualize it, essentially you're going to have points which contact your central angle. So just updating our notes here. Arcs, once again, in our little notes down here in the bottom, we have FH written down, but arc can also be something like EF, FH, HB, so on and so forth. These arcs here, since we don't have a radius measure as of right now, we can't use some of our Unit 8 type of content to then go ahead and extract out and theorize what a circumference or things like area might be, because we need additional pieces of information. What we're going to do now is take a look at just some examples. Your lesson for today is pretty short. I know you guys watched one video already today, so I'm not going to cram a bunch of extra stuff in your mind. We're basically just getting the nuance of the verbiage for this particular unit. So in this example here, we're going to have another circle. This circle, which we can label circle A, has two radii extending out, DA and AB. We also have our diameter of DC. So here, our first question is going to ask, list 3 segments shown that represent a radii in this particular circle. So 3 that we can contact would be DA, AB, and AC. Our next question is asking us what our diameter is. It's going to be DC. Next, we're asked, list all the chords that are currently shown. You can say dB and DC. And once again, if we're looking at essentially what our chord is, our focus point, a segment whose endpoints are both on a circle, we can mention dB, we can mention DC as well. Reason why we couldn't use AB, AB is just a segment, it doesn't keep on extending all the way out to the other side of our circle as well. When 7 o'clock, people cheering for doctors. The next portion that we're going to look at here, our next question, lists 2 central angles that are currently shown. Our central angles are going to need to have that center point associated with it. We're talking angles DAB and angles BAC. So just take note here, angles DAB and BAC are not going to be congruent, but we could say theoretically that our top portion is supplementary because of our definition of a line. Our next question here, name an arc intercepted by acute angle BAC. First thing we're going to have to do is find angle BAC, which is just over here. Our intercepted arc meaning our arc which has a center point, is going to be BC. And just take note when you're drawing that arc, you're doing that little semicircle essentially above. Next up here, question 6, we're being asked extend a chord to form a secant on the diagram above and write the name of your secant here. Based on our definition, our secant, we're going to extend out. It's going to go through our circle, intersecting at 2 points, and since it's a line, it's then going to go on for infinity. In terms of our notation, we have to make sure that we're adding those additional arrows, and then we're going to say we have line DB, and don't forget the arrows on your notation as well. Sometimes you'll also see, like, it'll say like line L with that lowercase m or lowercase l. Just have to make sure. One of the things to focus on as a secant, you'll probably want to label the actual points for intersection. Next up here, second to last portion, where our question is draw a tangent with a point of tangency at point B. Our tangent, once again, just taps the circle, almost like a little Happy Gilmore style, a little tappy tappy. Just intersecting, just not even intersecting, just brushing up against the circle. It's going to be our tangent here, just barely touching. So I like this last question. At first it makes you think a little bit here. So I'd like for you to respond here on Edpuzzle as well. But explain why triangle DAB must be isosceles. Now to answer this particular question, we have to consider some of our definitions here. The first major thing we have to think about is obviously what encompasses our particular triangle. What are our sides? What's cool here, 2 of our sides are radii. We both have radii AB and radii AD. Since we have 2 radii, we have 2 congruent sides. Since we have 2 congruent sides, we can say that we have our isosceles triangle, essentially. So if you want to just do a little notation here, what I wrote was that segments DA is congruent to AB because they are both radii. The 2 sides are congruent. So you have our isosceles triangle because we've got 2 radii indicate 2 congruent sides, 2 congruent sides of a 3-sided figure indicates isosceles. That's all of our notes for today. Video, as I mentioned, it's not too incredibly long. I want you to focus on these definitions. You once again, to reiterate for your work for today, you have one independent packet to download and answer the questions. It's split in half. One half being your previous lesson, the end of Unit 8, the second half being essentially what we just did on this particular page here, is answering some short questions. Your exit ticket for today is going to be corresponding with your Unit 8 questions, so hopefully you took my advice and just focused and did that already. Lastly, for today, you should have some homework. As I mentioned previous video, where I'm deciding to make your independent practice normally shorter now and easier. Your homework is going to have slightly harder questions. So you'll have about roughly the same amount of content, but it's going to be broken up now into multiple days, so you have a little bit more flexibility in terms of completing your work. All right, so got questions, anything like that, check me out on Zoom, 1:30 to 3:30 for our office hours. Yeah, and I hope you had a nice spring break and everything went very well. If if you need help with anything, once again, you can always message me. Got questions, anything like that. All right, have a nice day.